And so today we're going to introduce oxygen-containing organic compounds, and we're going to start going through some of the naming for them. If we had, let's say, C3H8, right? So C3H8. We would draw it out full structure like this. We could write it shorter if we wanted. That would be one version. You could do it without the bonds if you wanted, just CH3, CH2, CH3. Or the skeletal drawing where we would just draw the bonds. Each point and each intersection was a carbon. Circles added for emphasis. We don't really include those in the drawing. The idea was there was an atom, there was a bond between them, and then there was another atom. And that line is the bond. Well, when we have atoms that aren't carbon or hydrogen, so all the others are called heteroatoms, the oxygen, the nitrogen, the sulfur, the fluorines, the chlorines. When these are parts of our molecule, so let's look at C2H6O. So 2 carbons, 6 hydrogens, oxygen. We're going to put it together as, let's do the full drawn out, carbon, carbon, oxygen. So we can draw it full structure showing everything. We can try to shorthand it a little. CH3, CH2OH. And if we want to do it as a skeletal, well, we have our first carbon go to our second, and our second carbon goes to oxygen. Now this is important. I'm going to color code those carbons real quick. There's a carbon, there's a carbon. There are only 2 carbons, the end and the intersection. How do we know they're connected? There's that bond. This bond here is kind of showing that they're connected to one another. Well, we have a carbon and we have an oxygen. How do we know they're connected? There's a bond there, showing that they're connected to one another. What's important is that the end of that bond ends on the oxygen. Occasionally folks will accidentally think that there's a carbon mixed in. That is not the case. That is very important. That bond goes from carbon 2 to the oxygen. Now, that oxygen also goes to a hydrogen. And this is where we get a little different. Hydrogens, in skeletal drawings, hydrogens on carbons are left off. But they are always included on every other atom. It is only the ones on carbon that we can ignore. Because whether or not there's a hydrogen on oxygen is very important. Like there are reactions where that hydrogen leaves and that changes what oxygen looks like. So we need to draw any hydrogen that is on any atom other than carbon. So let's go to green. This is our CH3CH2OH. And if you had had the other version, 3 hydrogens on a carbon to an oxygen to a carbon with 3 hydrogens, you can also draw this, you can draw this as carbon to an oxygen and an oxygen to a carbon. And so the skeletal drawing, the end point is a carbon, but because that line is drawn towards another atom, a written in atom, it is assumed that the end of that bond is attached to that atom. So this only has the carbon here and the carbon there. So this, when we want to include non-carbon atoms, non-carbon hydrogen, we have to recognize the difference of what's at the end of those bonds. It is showing it bonded to that oxygen. So, well, we will see that for many, many atoms. Let's talk about what that group is. When I have other functional groups, we tend to focus on them more than the carbons. Like, yes, alkanes, alkenes, and alkynes, there was nothing else to look at, so the carbons, hydrogens were important. Generally, if there's any other atom, they tend to be more important than the carbon and hydrogens. So this molecule is mostly about that carbon OH, that COH bond. This is an alcohol. We write the general formula as ROH. R means any alkane. So earlier, that ethyl chain, that was our R group. If you have one carbon and an OH, then the CH3 is your R group. If I have a ring and then off to an OH with the CH3, all of that is an R group. R is just any alkane. Because the idea is it really doesn't matter what the rest of R is. We're looking at the part that goes carbon, oxygen, hydrogen. And if you ever have that, if you have a carbon to an oxygen to a hydrogen, and that carbon goes off to only carbons and hydrogens, and whatever numbers. So there's no other, like nitrogen, no other oxygen. If that's the case, that is an R group. And so it's just an easy way to say we don't care what the rest of it is, as long as it's some kind of carbon and hydrogen. Well, alcohols, they have their own suffix. All functional groups have their own suffix, and an alcohol ends in OL. So when I have the one we drew up above, which was CH3, CH2, OH. And you'll notice sometimes we put the bond between the O and the H, and sometimes they're just written adjacent to each other. That is the same thing. It just depends if we're trying to emphasize it. Chemists, we're kind of a little bit lazy, and that hydrogen just is written right next to the O. But it's the same thing as having a dash showing the bond. So if I have this, it is an alcohol. I have a hydrogen to an oxygen and an oxygen to a carbon, and that carbon just goes off to hydrogens and carbons. So I have a 2-carbon chain that is the R group, and I have an OH. Well, we name it by first naming the longest chain. That includes our functional group. In this case, it's just the chain. So it is 2 carbons long. 2 carbons was an F chain. So we have parts. There's the length. There is the ane, ene, ine component. And then there is the functional group. Suffix. The difference here is to merge these, we actually get rid of the E. I should use a different color. So we're going to get rid of that E. So we look at the carbon chain, we say, hey, all those carbons, they were single bonded. So that would have been an ethane on its own. But because it has the alcohol, we have to append the OL. So if it had only been 2 carbons in a line, it would have been ethane. But because it has a functional group, it is ethan, we drop the E, and then the functional group, ethanol. Merge it all together, ethanol. This is ethanol, 2 carbons and an OH. If you have 1 carbon and an OH, that is a meth. And all. No spaces. We said 2 carbons with ethanol. If I have 3 carbons and then an OH. So carbon 1, carbon 2, carbon 3, then OH. This is 3 in a line. It is a prop. They are all single bonded between carbons. It is a propan. And then it is an alcohol group, so it is a propanol. it is possible to have double bonds. And if that's the case, we would change AN out for EN. So if you had this molecule, again, I have 3 carbons, 1, 2, 3. So it is going to be some form of prop, and it is an alcohol, so it's going to have an ol at the end. Problem is the numbering. Now, we said we want the lowest for the double bond when that was our only functional group. In this case, we have something that's not carbon-based functional group, and that wins. If you have a double bond and then you have an OH, the OH takes priority. So the numbering for it becomes 1. Now, the carbon the OH is on is carbon 1 because it's the end of the chain. I had a choice between the left and the right. The 1 with the OH gave me the lowest first number for OH, so 1, 2, 3. Well, this means I have a 1-position alcohol and a 2-position double bond. Remember, if you had a double bond, you had to tell where it was. So it's a propene, definitely going to have an EN in there, but it is a 2-position ene, and it is a 1-position ol. Prop 2-ene, 1-ol. And so we can include double bonds and even triple bonds. Generally, we're not going to have a lot of that. It'll be single bonded. But this is where the AN or the EN before the functional group comes from. We still tell you what the carbon chain was like, but the very end of the name is telling you about the new functional group, the non-carbon functional group. Well, let's do a little practice then. So I'll draw a few here, pause it, take a minute, give them a shot, and then come back and see how well they match up. So let's do, there's our first one. There's our second one. Here's a fun one. Try that one, and we'll talk about that in detail once you're back. And then let's do our last one. So give those 4 a try. Go ahead and pause it here, and I'll see you in a minute. Okay, if you gave it a try, let's start our first one up here in the top left. So what we see here is that I have my alcohol group, and it is on a carbon there, but it's not on the end of the chain. So when this happens, we still have the longest chain. My chain here is 3 long. 1, 2, 3. Now, either direction I number it, it's going to put the OH on the 2 position. If I had a slightly longer chain, one of them might be a better place to start from. But in this case, I still want the longest chain that includes my functional group. Your functional group doesn't have to be at carbon 1. It just has to be on the longest chain. So I've got my longest chain. It's at the 2 position, so my chain is a prop. The carbon-carbon bonds are all single bonds, so it's a propan, and it is a 2-position alcohol. Propan-2-ol. Sometimes, because of old naming, the numbers, if there was only one spot the number could go, sometimes they were at the front. So a 2-propanol is the old name for this. Modern IUPAC is absolutely puts the number by the thing that it is involved with. However, small molecules that have been around so long that their names have really not changed in industry. So 2-propanol is still very common. Propan-2-ol is the technical name. And if you go way back, and you'll still see it marketed this way, this is also called an isopropanol. If you have rubbing alcohol, this is isopropanol. And so we'll talk a little bit of those really old names because some of them persist to this day. However, we are focused on the IUPAC systematic propan-2-ol. Let's jump over here to the right. So I have another molecule, this one. Well, it's got a bunch of different directions. There's a bunch of carbons. I could do a 4-carbon chain, or I could do a 1, 2, 3, 4, 5-carbon chain, or 4. The longest is 5. Question is which side to start from, left or right? Well, I want my OH group to be as low as it can be. So 1, 2, 3, 4, 5. Which means I have a methyl coming off position 3. So I have a 3-methyl. I have a 5, so that's a pent. So there's a pent. For the chain, it's all single bonds. It's a pentan. 2-ol with a 3-methyl. So I combine it. The name is 3-methyl pentan 2-ol. And so subgroups, when you have functional groups, go out front just like they did before. There's no change in that. The only real change is that you have to be a little concerned about numbering, getting your functional group as low as possible, and appending that functional group and its number onto the very end. Let's look at our last two. Well, this is a 6-carbon system. 1, 2, 3, 4, 5, 6. But it's in a ring. So it's a hex for being 6, but it's a cyclo. So this is cyclo hex. So cyclo for a ring, hex for carbon number. Well, they're all single bonded to each other, all the carbons, so this is a hexan. But because there's an alcohol, it's not cyclohexane. If there was no alcohol, it would just be cyclohexane. That OH means we drop the E and we add our OL, our alcohol. Well, again, on a ring system, you get to choose which carbon's 1. So your alcohol is going to be the lowest position it can be. It's a 1-ol. In fact, since it's the only thing on there, it has to be carbon 1. So a lot of times you won't actually even see the 1. This will just be called cyclohexanol. If there's no choice but for a group to be at a certain number, then they often will leave out that number. Both are correct. By all means, do the systematic cyclohexane 1-ol. But just know that a lot of times, if there's nothing else and no other way it could be numbered, the number gets left off. So you'll see cyclohexanol if you look up the chemical. And finally, way over here on the right, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. 5 carbons with an alcohol on the end. This is a pent. It is all single bonded between carbons. It is a pentan. 1-ol. Now this one, that alcohol could be at different positions. Like you could have had an alcohol here, or you could have had an alcohol here. That number is required in this case. It's just in the ring, since you always get to pick what's carbon 1, no matter where you drew the alcohol, that would have been carbon 1. It makes a difference over here on the straight chain though. We have a pentan 2-ol, or a 2-pentanol, and we have a pentan 3-ol, or a 3-pentanol. Like I said, if there's only one functional group, there's only one thing to number, sometimes that number's at the very front in the older naming. And this is the idea of alcohol naming. It's just a new suffix, and in fact, all of our functional groups are going to work like this. Our carbon chain will still be determined by the longest carbon chain as long as our functional group is along it. So our meth, eth, prop, all our prefixes will be the same. Any subgroups just get put at the very front of the name, and the only extra is, instead of ending in an E for like ANE, we drop the E and we tell you the new functional group.